Hi guys, welcome to something different today. So this is a Learn Electronics Repair on-site special. So here I'm at a local hotel. I've got to look at the TV system which feeds channels to all the rooms. It's not working properly. So I thought you guys might be interested to see where I actually work when I'm outdoors and what sort of equipment these hotels use for the TV systems. Come on. So we go up the steps. So I'll just get a bit ahead of you, yeah?
Let's keep walking, let's keep walking.
And now we're at the top of the hotel. You can see that's quite a long way up here. Fortunately, the lift was working. When that thing's broken down, it's a long walk, I can tell you. I've done it several times. So what do we have here? This is this is a dish farm. We call this a dish farm, satellite dish farm. So this is where all the various satellites are received. I can tell you now, this one is for English TV. This one, smaller one, is for German TV and Spanish TV. And this one is for Italian TV, which is what we're trying to fix today. We have another large dish over there. That one actually is also used for Sky TV. So Sky TV, and this one I say English, this is BBC, ITV and the main English channels. So all this lot is wired into this little hut we have here. And this is where we're going to be working today. So, welcome to the high-tech TV system. This was installed years ago before I worked here by a guy from Sweden, no longer on the island. It's been modified and changed quite a few times. Regulars to the channel, you'll see me repair this thing a month or two ago. That's actually working just fine. This one is actually broken. This is for French TV, but we're not going to fix this one today. What we're going to have a look is this one, which is the Italian one. The reason this is not working is because the Italian channels, their free-to-air channels, have moved frequency. And this is still set to the old frequency. There's no buttons or menus on screen or anything, a screen we can see how we set this. So basically, we have to connect a LAN cable, which we're going to do now, and we can get into the configuration screen. Okay, so let's do it. Yep. Okay, so this is the configuration screen for this Transmodulator, it's called. So basically what the Transmodulator does, it takes a signal from satellite, and this has 8 tuners built in. It can also handle 2 different satellite dishes. So each of the 8 tuners tunes into a certain frequency, and then you can take the channels from that frequency, convert them into digital terrestrial, and then send them down to all the rooms. So up the top here, this is a high-powered RF amplifier. So all these boxes chain together, and the final signal comes into here, and it's then boosted, and that goes to what we call cab boxes. These are cabinets on each floor of the hotel, and from there it's distributed to all the rooms. There's 110 rooms at this place, so all of them have TV, and we have one more here so we can monitor what's happening. So just before I configure this, I'll explain to you how satellite actually works, because it probably doesn't work exactly how you think. So come on, let's go to the paper. So a quick lesson in digital satellite TV then. The satellites, which are in geostationary orbit, 27,500 miles away, about 40,000 kilometers or thereabouts, okay? And your satellite dish is plugged into the satellite. Now, on the satellite, it has a number of transponders. A transponder basically takes a signal from the Earth, from an Earth station, okay, up to the satellite, carrying TV channels, and it takes this on one frequency band, and then it retransmits the signal on another frequency band. Okay, And the retransmitted signal can be a fairly tight beam on a particular country, or it could be a very wide beam covering most of a continent. The tighter the beam, the stronger the signal for a given wattage of transmitter. So that's basically how satellite works. This is your uplink, and then this effectively is your area of reception. And the area of reception can vary from satellite to satellite, and it can also vary from one transponder to another on the same satellite. So the signal that comes down from the satellite is in the range of 10.7 gigahertz to 12.750 gigahertz. That's the transmission coming down from the satellite. To get the maximum number of transponders on a satellite to give as many channels as we can within this band, what they do is they alternate the polarization of the transponders. This is so you can put the frequencies closer to each other and therefore get more frequencies on one satellite without getting an excessive amount of crosstalk or interference. So basically on the satellite, the signals are either horizontally or vertically polarized, and generally speaking, as you work your way through from this frequency up to this one, the transponders will be vertical, horizontal, vertical, horizontal, vertical, horizontal. It doesn't have to start with vertical, by the way, but they alternate. So this is, as I say, to allow you to get more frequencies on a satellite within that band of frequencies, that bandwidth, yeah? So the first thing you need to know, the polarity is altering. Now, when the signal comes down to your satellite dish, on the front of the satellite dish is the little thing you see pointing at the dish, and the wire comes from this. This is an LNB, or low noise block. Its full name is an LNBD, low noise block down converter. And what this does is it takes the incoming frequency and it has a local oscillator, and by combining the two frequencies, what comes down the cable is the difference between the two. So in a universal LNB, that's what they have on this installation, you will have two local oscillators, or LO. The reason we have two is this. If we had one local oscillator, for example at 10 gigahertz, then coming down the cable would be everything from 700 megahertz up to 2.75 gigahertz. You have a very wide band of frequencies, and it's more difficult to make a tuner which will tune to every frequency you want within that band. So to reduce the band and therefore make it easier to develop the tuners, we have two local oscillators. One of them is at 9.75 gigahertz and the other one is at 10.6 gigahertz. And this basically splits this band into two. So by using the lower local oscillator, we can receive signals from 10.7 to 11.7. And that's about a gigahertz of bandwidth, yeah? Once we go above 11.7, we use the higher local oscillator, and this will give us from 11.7 to 12.750. And again, you can see we've got basically a gigahertz of bandwidth. So that's how this LNB actually works and what it's doing. It's dropping the frequency down, because you can't send signals of this frequency down a piece of coax, not easily, especially considering it's bending around corners. You don't know how long it's going to be. But you can send frequencies in this 1 to 2 gigahertz range down, okay? And that's why we have the local oscillator. So how does the LNB switch between horizontal and vertical? So when you choose a channel frequency, you have to specify horizontal or vertical. Well, the way it actually does it is by the voltage on the coax. So if we have 12 volts, it's one, 18 volts the other. I quite don't remember which one it is. I think 12 volts is horizontal and 18 is vertical. Go and correct me if I'm wrong, but it doesn't really matter. The point is that by switching the voltage on the LNB, because this LNB has a local oscillator, a mixer, mixing the two frequencies, it needs power, yeah, that comes up the coax. So by changing the voltage, you can select either horizontal or vertical. How do we select which local oscillator to use? Well, all the channels from 10.7 to 11.7, this is low band. And then all the ones above 11.7 to 12.75, this is high band. And we have to tell the LNB to switch to the correct local oscillator. The way that's done, it puts a 22 kilohertz signal on the coax. And it uses a 22 kilohertz signal to switch the LNB to the correct local oscillator. Okay? Now this should tell you something quite important, but I'll make it very clear. There are 4 quadrants with this LNB. So it can either receive signals that are on low band horizontal, okay, or on low band vertical. So that's by using one of these two voltages with a 22 kilohertz tone. You can't use them both at the same time. It can't be both 12 volts and 18 volts. The signal can't be present or not, okay? So you can either have one or the other. And the same applies to the other two. So you have high band and we have horizontal or vertical. Okay? And the important thing is, as I mentioned, you can only receive channels in one quadrant at a time. So inside that satellite transmodulator that we saw, what we actually have is we have 8 tuners. Okay, there are 8 separate tuners. Each tuner is a satellite receiver and it can tune to one frequency. On that one frequency, typically there'll be maybe 4 HD channels. There could be 10 or 15 standard definition channels. There can be a mixture of both, okay? Now our unit, which is at the top of the screen, has 2 inputs. 1 and 2, and these are your satellite dishes. So this is connecting to 2 different dishes or a single dish with a dual output LNB, for example. And on here we have to set horizontal or vertical from a drop down list, and once you've set it on that input, then you can only receive, for example, horizontal channels. And because these receivers are all receiving at the same time, this 22 kilohertz is either there or it's not. It can't be both. So it means that any of these tuners that are set to use that input can only use channels that are on one quadrant. So for example, on here you could have the first tuner onto input 1. This one could be on input 1 as well. This could be on input 2. Input 2, and this could be on, if this is for example on some channel on the low band 10800, that can be on any other channel in the low band, which is anything below 11.7, so it could be on 11.5 for example, okay, and it will use whichever polarity you set. If you have your second input on ours, again you could have more than one. Okay, of these tuners on that satellite, you could have 6 of them if you wanted, yeah. Or 6 on input 2, 2 tuners on input 1, but whatever these are on, they can only either be high or low. So all the frequencies must be below 11.7 or above 1.7. You can't set them to be using both, and this is why, one of the reasons we don't have a signal locked on our system. These 8 receivers built into there, by the way. Each one of these receivers will give you a list of channels on that frequency. You can then select whichever channels you want, and you can tell it to output those channels on a DVB-T, digital terrestrial signal. This is in a UHF band, 800 megahertz. It starts at, I think, about 500 megahertz. Somewhere in this region, yeah. So it transmodulates. It receives on one frequency, decodes, I don't mean descrambled because this is for free to air, but decodes the satellite signal, takes the channels you want, and then remodulates them on one of these frequencies, and then that goes down to the various floors in the hotel and to the various boxes. So that's how the system actually works. It's better on paper, yeah? You'll probably realise by this, by the way, that if you want to be able to receive any channel from a satellite, you need four inputs. One for horizontal high, one horizontal low, one vertical high, one vertical low, and you need 4 outputs on the LMB independent. So this transmodulator can only give you effectively half of the channels on any given satellite, or a quarter of the channels from 2 different ones, which is what we have. Another thing, by the way, there is a limit to how many channels you can modulate onto a terrestrial TV, digital video broadcast signal. This thing has a processor in doing that, and you can see a performance meter. It shows you how hard it's working. Keep them below about 80% modulation, otherwise when you get lots of movement in the pictures, the actual load changes, it's working harder, and you need a certain amount of headroom so that you don't overload the modulator. Otherwise what happens is all the channels start to pixelate. Okay, so that's how it works. Hope you sort of understood that, because I did it a bit quick, but I don't think it was too complicated. Let's have a look at ours now and see if we can configure it to work correctly. If we can, all is good. If we can't, there's a problem with the satellite signal. So you can see the configuration screen here. We have input 1 and input 2. And if we look at input 1, you'll see this is set to horizontal. So we're receiving horizontal channels from this satellite. This is Astra, these are German channels. And you can see the frequency is 11.836 gigahertz, 12604. These are all above the 11.7. So these are all high band. So they're okay, and we can see these are locked. The problem we have is number 5, which is unlocked on input 2. And we're trying to receive 11.766 gigahertz, which is high band. But on input 2, we're also trying to receive 11.034, which is below 11.7. That's low band. And we can't receive them both at once. So you'll see that number 7 is actually locked, but number 5 is unlocked. So to fix this, I'm actually going to change number 7 to a high band frequency. Although it's locked, I don't think we're actually using any channels from this. Let's have a look. So here we can see input 7, and you can see the channels on here. Okay, these are a list of channels on that frequency. But if you look at the other side, enable says off. They're all switched off. So we're not actually using any of those channels to go to the rooms. So I can change this to another high band. So let's do it. We're going to change 7 to 11727V. So 11727 vertical. They're all on vertical. We'll save that, update.
Give it a sec.
Give it a second. And if this isn't locking, there's not a problem with the dish. They're both high band now. That really surprises me. It's obviously just not seeing the signal. Now we did see the signal on some frequency. Remember on the low band it was seeing the frequency.
I wanted to be sure.
Yeah. There's not a very good connection here to the braid. You see it? But I think there is a connection. just wasn't very good on the braid on the end of here. Okay. Make sure I do have a connection. Okay. Thing is, this is ancient. This is called the C120 and you can't easily get them anymore. We might have some fun with this round. No, it just says digital LMB. Right. Right. Let's just shut that down.
Oh yeah, right.
So guys, you can see that wasn't totally successful. We've now got the correct frequencies in, but we don't have a signal on this one. This is the dish. Now, these dishes have been here for many, many years. And if there's a problem with this, it's going to be the LNB. This is the thing on the front. These dishes are so solid, there's no way these are going to move out of line. Plus, it basically looks to me it's pointing in the right direction. The problem is that I find these type of LNBs, this is called the C120, this particular mount are very hard to find. So I really have two choices now. One is to see if we can find an LNB, that would be the easiest. So I'll go have a look, I'll probably look on eBay. I know the local distributor does not have these. Another one is to replace this dish. Now, this dish is bigger than it needs to be for this satellite. So if I am going to replace it, I'm going to replace it with a modern dish, this type, with this type of LNB on. And I'll fit it off this wall somewhere. It'll probably be a similar size to this, maybe a little bit larger, 1 meter. We don't need something, I think that's a 1.2. Yeah, something like that, maybe a 1.5. Okay, so not a totally successful job today, so we've got to come back and do this again as soon as I get the dish, LNB. But while we're here, we may as well admire the view, have a look around, and I think this is a lovely place. So, hope you enjoyed that. We'll see you all soon. Ciao for now, guys.